Hello, pre-calc students. I am going to be doing the Chapter 5 test review to help you prepare for your test tomorrow. Number 1 goes along with Section 5.1, where you're going to be using the identities to simplify this fraction in order to reduce it down to one trig function. And you may want to revisit all of your identities or go to Quizlet.com to do some flashcards on those identities to help you remember them. I am going to do this pretty quickly to keep the video in within probably 15-minute range. If you need to stop the video, please do. Replay parts. Do what you need to do in order to help yourself. With that said, a couple of people have come up to me and asked me how to focus or start this question, and I've told them to focus on just the bottom part and pretend like the cosine is not there. We're going to add it in the later part of the problem. So on the bottom we have cosecant x minus sine x. And what you can redo is rewrite cosecant so that it's 1 over sine. And then use the process of getting a common denominator so that you can combine the bottom part to be 1 minus sine squared x all over sine. This top part, 1 minus sine squared x, is equal to cosine squared. That is one of your Pythagorean identities. So on the top, this is going to become cosine squared all over sine. There's not much I can do from this point, so what I'm going to do is say, okay, this is the whole bottom. And on the top, here we're bringing it back. We still have cosine x. Flip and multiply. So you're dividing by a fraction. You can multiply by its reciprocal. So you're going to get cosine x times sine x over cosine squared x. These cosines will reduce. You still have a cosine on the bottom. And sine over cosine is tangent. At this point, you should maybe stop the video, try it on your own, or redo it on a separate sheet of paper. The next problem is number 2. We are also using the trig identities. This time we're going to use them to verify the identity that's listed, pretty much show that this side is equal to that side. What I would do to get started is pick a side to work with. I think it's easier to go from addition and subtraction to multiplication. So here we go. If there is a negative identity, I will give that to you tomorrow on the board. But this will become negative tangent x minus negative tangent x. And that minus and negative will become a plus. At this point, if you're not sure what to do, maybe write everything in terms of sine and cosine. So this is going to be cosine over sine. And this is going to be sine over cosine. Just like the last problem, we're going to use our skills of getting a common denominator. So I'm going to multiply this one by cosine, or no, sorry, by sine over sine. And then take this one and we're going to multiply by cosine over cosine. What will happen is that you're going to get cosine squared and then plus sine squared all over the common denominator of cosine sine. This is a Pythagorean identity. Cosine squared plus sine squared is all equal to 1. So that full numerator is going to become 1. If you can see that this is equal to secant cosecant, you could go straight to that proof and just put a check mark. I'm going to split it up so that this is 1 over cosine times 1 over sine. And 1 over cosine is secant. 1 over sine is cosecant. And there you go. Sorry. 1 over cosine secant, 1 over sine, whoops, there we go, is cosecant. And that's what you're looking for. Again, maybe stop the video, get a separate sheet of paper, try this one on your own, see if you can end up with the same thing. Moving on, we are going to do question number 3 and question number 4. And both of these deal with solving trig identities, or sorry, solving trig equations, and they are going to incorporate the unit circle. Some things to remember, maybe identities are going to come in handy. Maybe if you take the square root of something that you're going to have plus and minus. Let's see where this ends us. Or let's see what we run into. Another thing that's often asked is if I'm finding the angles on the interval 0 to 2 pi, this is the case where you don't have to write 2 pi n. I'm pretty sure on the test I keep it on the interval, so you can just assume that you don't have to write plus 2 pi n in your final answer. So here we go. I would add 12 to both sides because the first thing that you want to do is isolate the trig function, so get this tangent all by itself. So add 12, divide by 4. And 12 over 4 is 3. At this point, to isolate tangent even further, we need to go ahead and take the square root of both sides. And keep in mind, a lot of people forgot this on their quiz, that you're going to get plus and minus the square root of 3. Right, not just the positive square root of 3. At this point, our trig identity or trig function is all by itself. I wonder if I can maybe zoom out so that you can see more. And our answer, or I guess to get to the angle answer, what we need to do is search around the unit circle to see where tangent is equal to positive or negative square root of 3. These do go with that coordinate. So this first angle is going to be pi over 3. The second one will be 2 pi over 3. Down to the bottom of the unit circle, we're going to have an answer at 4 pi over 3 and another at 5 pi over 3. At this time, you can pause the video and try the question on your own, or take a separate sheet of paper out and redo it. The next question, number 4, is similar to the previous question. The thing that makes it a little bit different is that we have this 4 theta inside of the parentheses. And I have a lot of students that would want to divide by 2 and reduce that 4 inside of there. Keep in mind, and I believe I'll include parentheses tomorrow, the parentheses mean that I have to, or that you have to keep that 4 theta all by itself until the very end. So from the beginning, let's go ahead, start working on isolating that sine x, or sine 4 theta, I should say. What you're going to do is add 1 and divide by 2, so that you get sine of 4 theta is equal to 1/2. Another good thing about not dividing by 4, or not dividing the 4 by 2, is this 1/2 is on the unit circle. And if you were to divide 1/2 by 4, you wouldn't get anything that's on the unit circle. So at this point, what I would do is go and find out where regular sine is equal to 1/2. One of the answers is going to be pi over 6. Another of the answers is going to be 5 pi over 6. So this happens at pi over 6, 5 pi over 6. And normally we would set just theta equal to those, but we don't just have theta, we have 4 theta. So to finish off the problem, all we need to do is divide each of these answers by 4. Same thing as multiplying them by 1/4. And you're going to get, let's see, 6 times 4 is 24. So pi over 24 and 5 pi over 24. At this point in time, maybe pause the video, retry for number 3, so that you get the practice of solving trig functions for theta. Number 5, we are going to use the sum and difference formulas. I know it's not quite as apparent. Maybe I can zoom in. There we go. Sum and difference formulas. The first thing that I notice is that this is cosine of a plus b. What we can do is use that cosine addition formula in order to rewrite the first part of this statement in order to simplify the expression. I'm going to cover this up for a second just to show this is going to be the formula sheet that I give you tomorrow. You can kind of see that we have cosine of u plus v, and here's the expansion part of it. That is going to be the formula format that we use to start this problem. So cosine of x plus 3 pi over 2 is going to become cosine of x cosine 3 pi over 2 minus sine of x sine 3 pi over 2. That is all one whole quantity. Put parentheses around it, because what you're doing is that you're going to then multiply everything by sine x. Because he's right there. He's on the outside. At this point, after you've expanded it, if you can, go ahead and find cosine at 3 pi over 2 and sine at 3 pi over 2. One of them ends up being 0, and that's pretty nice. In fact, it's cosine. So this becomes 0, and this is negative 1. What will happen is that the 0 quantity will have no effect on the quantity on the inside of your parentheses. But here we have minus negative sign times the negative 1. So on the inside, this whole entire thing is going to become positive sign. So this becomes negative 1. Negative 1 times negative sign is positive sign. Don't forget about that sign hanging out. And sine times sine is sine squared. At this point in time, maybe pause the video, retry this question. The next question also involves the sum and difference formulas, but in a different way. Moving on to the back, we have question number 6. Question number 6, like I said, does involve these sum and difference formulas. You will be given this formula sheet. What I would do is ask yourself, what format does this look like? And if you kind of look at the top, you have a tangent plus a tangent. That's going to look like this tangent u plus v. So all of this is going to condense into tangent of u plus v, where u is just x and v is negative x. So you're going to get tangent of x plus negative x. X plus negative x is 0. And tangent at 0, if you reference your unit circle, is 0 itself. I am running out of time, so I'm going to upload this part of the review to the website. 7, 8, 9, and 10 we were able to do in class. So if you do need to watch those, I am going to do them as well, but they will be on a separate video. I hope this helps, and good luck with your studying.